Welcome back. Till now, we have learned the basic of linear equations, and now we will move on to do some 8th grade problems from SpringBoard Course 3. We will start from lesson 10-1, page number 119. Before we start, there are three properties we're going to use a lot throughout this lesson, and those are the distributive property. We have talked about this before, but let's review this again. So in the distributive property, I'll give you an example so you could recap. So A parentheses B plus C, and that equals in distributive property AB plus AC. Another property that we already know, but let's just recap, is inverse operation. And inverse operation is doing the opposite of the operation that's already done. Okay, so 2x is our term, so the inverse operation would be dividing this term by 2. And a new property we're going to learn is multiplicative identity property. In that, it's in any time you multiply a number by 1, so the result is the original number. So you should review these three properties before starting. So let's start with activity 10, lesson 10-1, page number 19, and let's start with number 1. So the question says, if the scale is balanced, how many cubes must each bag have? Explain how you determine the answer. So the diagram shows some small lightweight plastic bags containing an equal number of centimeter cubes that are placed on a balanced scale with some additional cubes. So this is the additional cubes, this is the plastic bags, and this is the cubes that these stuff are equal to. So what we can determine the answer since there are 3 cubes here and 7 cubes here, we could take away the cubes, 3 cubes and 3 cubes from here. So you could just do this, and then you could see that there are 4 cubes left here and 2 bags left here. So then you could equally divide this into 2 bags, and then you could see there are 2 cubes in each bag. So that's how I determined my answer of 2 cubes per bag. And let's move on to the second problem. The second problem says, write an equation to represent the diagram above. Let x represent the number of cubes in a bag. So we already know that that there are 2 bags, so the coefficient of x has to be 2. And since now it's a different problem and the number of cubes in each bag could be different, the variable has to be x. And then since there are 3 additional cubes over here, then this has to be 3. And since the total cubes over here is 7, this has to be 7 over here. So let's move on to the next page. So right now we're at page 120, lesson 10-1, activity 10. So let's go to question number 3, and let's read the question together. One way to solve the problem involves removing equal amounts from both sides and then regrouping the remaining cubes. The diagram below illustrates this process. The first diagram is the original diagram, which Write an explanation for both the second and third diagram to the right of each. So we had to write the explanation over here, and this is the original diagram, and and we don't need to really write an explanation here because it says only for the second and third. So for the second, we see that they're removing 3 cubes from each side. So that would be the second diagram shows the amount of weight from both sides getting removed the same amount, and then that's 3 cubes. So we could write that over here that removing 3 cubes from both sides. And in the third diagram, we see that there's 2 plastic bags left and there are 2 cubes over here. And the third diagram shows the remaining cubes sorted equally among the 2 bags. So we see these 2 going here, these 2 going here. So we could just write the remaining cubes sorted equally among 2 bags. And from the diagram above, so let's move on to number 4. And it says, from the diagram shown above, how many cubes are in each bag. So we can see in each bag there are 2 cubes because there are only 2 cubes in this circle. So we could write 2 over here. And so for number 5, let's move on. The answers on the next page, but let's read this first. Model each of the following problems using bags and cubes. Then determine how many cubes are in a bag. Record your work using a diagram like the balance scale. Write an equation for the original problem and an explanation for each step and the solution. Let x be the number of cubes in the bag. So, let's read 5a. If 3 bags are on each side, which is like this, 3 bags are right here on each side of the scale, and 12 cubes are on the other side. So there are 12 cubes right here. How many cubes must be in each bag to maintain the balance? So what we could do, all we need is, if we go back to number 3, so we need only this step right here, because since there are no additional cubes in item 5a, so we just need the remaining cubes sorted among the 3 bags instead of 2. So that would be our explaining step over here. And if you look, this is actually 4. So there are actually 4 cubes in each bag, because 4, 4, and then 4. So let's move on to 5b. If 3 bags and 10 cubes are on one side of the scale and 16 cubes are on the other side, how many cubes must be in each bag to maintain the balance? So we should draw 10 cubes right here and 3 bags right here and 16 cubes right here. So that would be our model. And then in this one we have to use all the steps of the number 3. We have to use this one, unlike the last time we only used this one. So first, it would be removing 10 cubes from each side. So that would result in 3 bags and 6 cubes. So that would be, and then we'll be putting remaining cubes, sorting remaining cubes among the 3 bags, and that would be 6 divided by 3, which would result in 2 cubes. So let's move on from page 121, activity 10, lesson 10-1 to page number 122, lesson 10-1 and activity 10. So let's do try these 8 problems. So let's do number B first. So the number B says -1/3 x plus 4 equals 12. So that's our original equation, so we should write that as our first step. And then, since we had to use inverse operations, we should add 4 to both sides because we're subtracting 4 over here. And then that leaves us with negative 1/3 x equals 16. So what we have to do is we have to times both sides by negative 3. So we could just do this. So that will leave us with x equals negative 48, and this will be our answer to this. And if you want to verify it, you could put it back in the equation where x is, so you could put negative 48 right here, and you could verify it if you want to. So, and let's also do problem D for more practice. So let's write the original equation first. Okay, and then since we have to use inverse operations, we should subtract 10 from both sides because we're adding 10 right here. And so that leaves us with 3x equals 6. And since we're multiplying 3 here, we should divide 3 by both sides. Divide by 3 on both sides. So that leaves us with x equals 2. So that will be our answer. And then again, if you want to cross-verify, you can. I'm not going to solve all of these. I want you guys to do it because you already had practice with 2 problems. So I want you guys to do A, C, and E on your own. So number 6, it tells us that we have to solve how does solving equations algebraically represents a bag and cube process. Well, you could just pull some connection from here, that here you subtract stuff and then also divide, and then in the previous bags and cubes you remove 3 from both sides, and also you divide 4 cubes into 2 bags. So that could be the similarities. So now we should move on to number 7. So number 7 says, use properties of operations or other explanations to describe each step in solving the equation. 3 parentheses x subtract 2 and parentheses equals 8. So first, they wrote the original equation, which it says over here, and then the next step is 3x subtract 6 equals 8. So what they did here is they multiplied 3 with x and multiplied 3 with negative 2. So that property is a distributive property, so we should write that in the explanation over here. And then what they did is they added 6 to both sides, and that would be the inverse operation and adding 6 on each side. So that's what they did. And they did that because we're subtracting 6 here, so the inverse of that would be adding 6. Then this is simplifying, and then in here they're dividing 3 by both sides because you're multiplying 3 by x over here. So the explanation for this step would be inverse operation, divide 3 on each side. And then this would be simplify, and then lastly this would be use multiplicative identity property to isolate the variable. That would be because there was a 1 here and now it's gone, so we use multiplicative identity property to isolate the variable. And let's move on to the next page now. So we are at page 123, activity 10 and lesson 10-1. So let's start with problem 8. I'm going to check your understanding. Len is spending summer vacation hiking in Canada and wants to dress appropriately for the day's hike. The local news reports that the high temperature is expected to be 20 degrees Celsius. Use the formula F equals 9/5 C plus 32, where C is the degrees Celsius and F is the degrees Fahrenheit, to determine the local temperature in degrees Fahrenheit. So we should probably underline the question so we know what the question is, and then we can solve it on the side over here in the My Notes section. So the first step would be writing the equation they gave us. So let's write that as a first step. Okay, so in our second step, they give us this number value of 20 degrees Celsius. So we should put that in this Celsius place, which is right here. So let's substitute in 20 degrees Celsius as our second step. And then, as we learned that we can cross multiply, and then we can also simplify like this. So 5 would become 1 and 20 would become 4. So then you could do 9 times 4, which is 36. So we could do f equals 36 plus 32, and you can combine these two together. That will equal f equals 68 degrees Fahrenheit. And make sure you write the units too, because it's a real world situation. So this will be our answer. And let's also solve number 10. So first, let's write the original equation, which is 5 over 2y equals 10. And the question number 10 says, solve 5 over 2y equals 10 for y. So in that, we have to solve for the variable y. So first, since we have no constants to move over here, all we have to do is isolate this variable. So what we could do is we could do the reciprocal of 5 over 2, which is 2/5, and we can multiply this and this by 2/5, and that would isolate the variable. And as you know, if we cross multiply, we can also simplify this way. So that will leave us with 1 and 2. So that will leave us with y equals 4 as our answer. And if you want to cross verify, you could put it back in the equation. And same for the above question. If you want to cross verify, you could put it back in here. And number 9 is the same as number 10, so I'm not going to solve it. I want you guys to solve it. And number 11 is also the same as number 10, so I want you guys to solve it because you already had practice with number 10. So number 12 is also pretty similar to number 10, so I'm not going to solve that one either. And number 13 is almost the same as number 10. So number 14, I'll go over it a little bit because this might be a little tricky, but we already did this on the previous page, page 122, question 7. We already did this, so this might be a little tricky, so I'll just still go over with this, you guys. So in this, it shows that we're combining like terms, negative 5y and 3y, and combining it to negative 2y. So this will be the combining step, and then this will be inverse operations because we're subtracting 7 from both sides because we're adding 7 out here. This would be the simplify step, and then this would also be again inverse operations because we are dividing to negative 2 because there's negative 2, and y are multiplying, and then this would be our answer. So let's solve 15 because this might be a little tricky. We didn't encounter this type of problem yet. So let's write the original equation over here first. X plus 2 parentheses divided by 7 equals 14. So let's read the problem and what we have to do. So number 15 says solve for x in the equation x plus 2 parentheses divided by 7 equals 14. So we have to solve for the variable x over here. So first what we have to do is we probably have to get rid of the 7 over here. We could do that by multiplying both sides by 7. So let's do that first. Multiply both sides by 7, and that will give us x plus 2, which equals 98. And then we have to isolate the variable. We have to get rid of this 2 right here. So we have to move the 2 over here, and we could do that by subtracting 2 on both sides and using inverse operations. So that will leave us with x equals 96, and this will be our answer. If we want to cross verify, you could put 96 back in the equation right here. And number 16 is just like number 10, which we already solved, so I'm not going to solve it again. I want you guys to solve it. So let's move on from page 123 to the next page, which is 124. So once again, we're at page 124, lesson 10-2. We moved up a lesson, and activity 10. So let's try these A. I hope you read the example A right here, or I could read it too. So in example A, it solves the equation 12x plus 5 equals 6x plus 17. So in step 1, they use inverse operation to combine like variables on one side of the equation. So they put the like variables from here to here, and they subtracted 6 on both sides. So this equation was equivalent to 6x plus 5 equals 17. Then there's the inverse operation to subtract 5 from both sides because you're adding 5 right here. So this was equivalent to 6x equals 12. Then they use inverse operation to divide both sides by 6 because you're multiplying 6 by x over here. And then that resulted in 1x equals 2, and then they use multiplicative identity property to isolate the variable, and then that gave us the answer of x equals 2, and then they plugged in the answer over here to cross verify, and then it was correct because the equation matched on both the sides, so 29 equals 29, so this was correct. So then we will do the same, try these A, which is kind of like example A. So we'll do this. So let's start with number D. Okay, so first in number D, it says 8 subtract x equals 3x plus 2, in parentheses, x subtract 4. So we should probably write the original equation right here, which is 8 subtract x equals 3x plus 2, in parentheses, x subtract 4. So, since I don't have space to provide the explanation for each step over here, I'll just verbally tell you guys the explanations. So first, what we'll do is we'll use distributive property to multiply 3 to x and multiply 3 to negative 4. And you could, another way to think about it is, because of GEMDAS, you do multiplication first and then you do addition or subtraction, so you could think of it as that way too. So then that would give us 8 subtract x, which equals 3x plus 2x subtract 8. So then we have to combine like terms, which are these two, so we have to combine them together. So that will give us 8 subtract x, which equals 5x subtract 8. And then we use inverse operation to put 5x over here, and then it will put negative 8 over here. We'll do that in the next step. So in this step, we subtract 5x and subtract 5x, and we put the isolate the constant over here. So that will lead us to 8 subtract 6x equals negative 8, and then we'll subtract negative 8 from here and put it here, because then we can isolate this term. Subtract 8, subtract 8. That will give us negative 6x equals negative 16. So then, what we're gonna do is, so what we're gonna do, then we have to divide these two, because since we're multiplying this, we use inverse operation to divide on both sides. So we'll divide by negative 6 and negative 6, and that will give us 1x, which equals 16 over 6, and then we use multiplicative identity property to isolate the variable, and that'll give us x equals 16 over 6. But this is still not done because this is an improper fraction, so we have to convert this into a mixed number. So that will be x equals 2 and 4/6. So, and then we have to simplify this because this is not, it gets simplified. So that will give us x equals 2 and 2/3. So that'll be the answer. And if you want to cross check it, you could put it back in the equation up over. And since A, C, E and B are all the same exact things. They use the same steps as D, so you could do these on your own. And then, so let's move on from page 124 to page 125, activity 10 and lesson 10-2. So we are at page 125, activity 10 and lesson 10-2. So I'll just summarize what this example says. So in this example, it shows a real world situation that has been modeled in this, and it has been solved, and also has been then this is the solution. And in example C, it's a little different from example B. This is not a real world situation, and the model of this is finding out the equation instead of a drawing like this. And then also they solved it and checked their solution, and their solution is 18. So let's do Chinese A number A. So it says create a model and solve. So we have to create a model, and since this is kind of like example C, we have to create an equation as our model, and we have to solve it and get the equation. So it says 2/5 of the number increased by 6 equal to 3/4 the number decreased by 8. So let's take it step by step. So our number, let's take it as x. So step 1 would be x, right? So this is our step 1. And our step 2 would be 2/5 of the number. So 2/5 of x. So that would be our step 2. And then step 3, put increase by 6. That would be plus 6 to this. Then we write 2/5 x plus 6. And then is equal to 3/4 the number. So we write 2/5 x plus 6 is equal to 3/4 that number. But we're not done yet. It also says one last one, decrease by 8. So it is 2/5 x plus 6 equals 3/4 x subtract 8. So this is our equation. So this is our model. And we just solve this and find what x is. Basically the number. We just find out what the number is. So let's rewrite our equation, which is 2/5 x plus 6 equals 3/4 x subtract 8. And then what we could do is we could subtract 6 from here and put it here. So we could do inverse operation first. So let's do that first. So we could just subtract 6, and that would result in 2/5 x equals 3/4 x subtract 14, right? And then we could subtract 3/4 and put it here. So subtract 3/4 x, subtract 3/4 x, and then that would equal in -7/12 x equals -14, and then we could multiply this by -12/7 because this is the reciprocal. So if you multiply by the reciprocal, this will equal x, and this we can isolate the variable. And then so we could do the same on the other side by -12/7. That will result in a positive number, because negative plus negative equals a positive. And then you could cross multiply it, so 7 would become a 1 and 14 would become a 2. So -12 times -2 is 24. So x is 24. So this is our answer, and if you want to cross check it, you could put it back in this right here and right here, and this both should equal each other. So let's move on from page 125 to page 126, lesson 10-2, activity 10. So, problem B of Chinese B. So this is the same as problem A, so I would like you guys to try it out. And I don't want to solve this because you already had an experience solving it last time. So let's do problem 1. And so problem 1 says, John and Danielle know that regular exercise strengthens your heart. They know that a person's heart rate should not exceed a certain limit during the exercise. The minimum rate R is represented by the equation. So since the equation is probably important, we should underline it so we know that we should go back here for the equation, where Y is a person's age in years. Determine the age of a person whose maximum heart rate during the exercise is 164. So what we first have to do is that we probably have to write the original equation first. But let me explain you this problem. This problem is all about finding the maximum heart rate of a person while he or she is doing exercise. The heart rate is dependent on his or her age, which is Y, which is given by the formula below. R equals 0.8 in parentheses 220 subtract Y close parentheses. Typically, we always find the output, and the question provides us the input. But in this problem, the output heart rate R is given, but we need to find the input, and that is age, and that's Y. And since we've never done this type of problem in this book, I think, so maybe I should go over this with you guys, and then you guys can solve 2 and 3 on your own, since we'll already have practice with number 1. So let's start by writing the original equation, which is R equals 0.8 and in parentheses 220 subtract Y. Okay, and then first we have to sub in our heart rate, which is 164, into R because that's the heart rate. So we sub it in over here. So we write 164 equals 0.8 and 220 subtract Y. And then we use distributive property because we can use distributive property. So let's distribute this 0.8 to 220 and Y. So it's going to be 164 equals 176 subtract 0.8 Y. And then I could use inverse property because since when it is not a negative sign here, there's always a positive sign. So we could subtract 176 from both sides, so that would be the inverse property. So let's do that. 176 subtracting from both sides, that would result in negative 12 equals negative 0.85. And since we had to isolate the variable, we had to do another inverse property and divide by 0.8, negative 0.8 on both sides. So let's do that. Negative 0.8 divided by negative 0.8. And that will give us Y equals 15. It's 15 because negative negative equals a positive and 1, and then since you have to make this into a whole number, you have to add a 0 at the end of this, so 120 divided by 8, that will equal 15. So then, since the variable has to be on the left side of the equation, then we have to switch this apart, so 15 has to be here. So I'll write it a little below because there's a math tip here. Y equals 15, and since we also have to put the units of this, and don't remember to put the units, don't forget them, so we write 15 years old. So this is our complete answer, and if you want to check it, you can plug in 15 and Y and check if you get the correct answer, and 164 in R. And so, like I told you guys, I want you guys to solve number 2 and number 3 on your own because we already did one type of question, number 1, like that. So, our next, let's read this little segment down below. That will lead us into our next problem, and that is, equation has no solution if there's no value for the variable that will create a true mathematical statement. An equation has infinite many solutions if there's an unlimited number of values for the variable that will create a true mathematical statement. So let's move on to the next page. So let's move on to page 127, activity 10 and lesson 10-2. So let's move on to question 4. So question 4, it says, critique the reasoning of others. Michaela, Ryan, and Gabriella solved the following 3 equations as shown below. Each student has reasoned their equation as having no solution, one solution, or infinitely many solutions, respectively. Why are the students correct here? So, let's read through Michaela's. Let's see if there's anything wrong here. So, this is the original equation. So then she did distributive property, so that's correct. And then she combined the like terms. Then she did the inverse operations, and she canceled out the variables, so that leaves her with 5 equals negative 35. So that is no solution because this equation can never be true, because 5 can never equal negative 35, so this equation will have no solution. So let's move on to the next one. So Ryan, his equation is 2 times x subtract 3 plus 5 equals 4 times x subtract 1. So first he did distributive property over here, so that gave him 2x subtract 6 plus 5 equals 4x subtract 4. Then he combined like terms, which are these two, and made a negative 1. Then he subtract negative 2 from both sides, so he could cancel out and put the constant on one side and variable on the other. So that leaves him with negative 1 equals 2x subtract 4. Then he plus 4 both sides because he's subtracting 4 here, so inverse operation of that is plus 4. So that leaves him with 3 equals 2x. So then he divided 2, because since you're multiplying 2 with x, you have to divide. So that leaves him with x equals 3 over 2. So since this is the only unique solution to x, so this equation has only one solution because the variable equals a single value, single and unique. So that's why it has only one solution. So let's move on to Gabriella's. So Gabriella's is, the equation is 6 parentheses x plus 1 subtract 10 equals 6x subtract 4. So in this, first she used distributive property to distribute 6 to here. So then she got 6x plus 6 subtract 10 equals 6x subtract 4. Then she combined the like terms and got negative 4. Then she got 6x subtract 4 equals 6x subtract 4. Then you can see from here that it's going to be infinitely many solutions, because this side is like the same as this side. But we should solve more to see that is it really going to be, just in case. So then she subtracted negative 6, subtract 6x from both sides because she's adding 6x. So she got negative 4 equals negative 4. Since it's infinitely many solutions, because the left side is identical to the right side, so that's why it's infinitely many solutions. And let's, for this, write a real, and number 5 says, write a real world problem for the equation 7x subtract 10 equals 3x plus 4. I'm pretty sure you guys could do that. It can be any, so you have examples of real world situation in the previous page of 1, 2, and 3, so you guys could take any of these on page 126 right here, so you guys could take any of these and use as problems here. So I'm not going to solve number 5 for you. We have already done number 6, 7, 8, and 9 on previous pages, like page number 124. So I won't solve that for you guys. I want you guys to solve it. So let's solve number 11, because this is a unique question. So first, it says create a model. So since we can't create an actual picture, let's create a equation, which is right here, but I'll tell you how I got to that. So since it says over here, so let's read this question 11A. It says create a model and solve. So in a recent basketball game between the Storm and the Chargers, the number of points scored by the Storm in the first half was equal to the number of points scored by the Chicago and Chargers in the second half. So we should probably underline this because this is important information. This might help us in the problem. And in the first half, the Storm scored 1/4 the total points scored in the game. We should probably underline this too because looks like important information. During the second half, the Chargers scored 16 points, less than 1/3 the points scored in the game. This is important too, so let's underline this. And this is our question: how many total points were scored during the game? So, a model we can make from this, since they're equal to each other, so there should be equal sign, and then it's 1/4. Since I got the 1/4 because it says 1/4 the total points, so I chose P as my total points, and I did 1/4 P, which equals 1/3 subtract 16. That's because it says right here that they scored 16 points, less than 1/3 the points scored in the game. So that's how I got my model. And I solved this by, let's go a little bit to the right, and I solved this by 1/4 P equals 1/3 subtract 16 P. So what you could do is you could put the variable on this side, so you could subtract 1/3 P, subtract 1/3 P, and that will leave you with 1/12 P, which equals -16. And then, since you know the reciprocal property, you could multiply this and this by 12. So let's do that by 12 and this by 12. So that shows that P equals 192, and since points can never be negative, we have to make this into a positive. So P equals 192. So that's how I got the 192 over here. And let's do number 11B now. Let's move on to number 11B. So 11B says 7/10 of a number decreased by 13 is equal to 3/10 of a number increased by 13. Find the number. So let's take the number as n. So we could do, so let's take the first person, 7/10 of a number. So we should write 7/10 n decreased by 13. So subtract 13, which equals 2. So we have to have an equal sign to 3/10 of the number. So 3/10 n increased by 13. So plus 13. So this is our model. And then if we could solve this model right here. So how we could solve this model is we should write the original equation, which is our model. 7/10 n subtract 13 equals 3/10 n plus 13. So first, let's get the constant over here, and then we'll get the variable over here. So plus 13, and that gives us 7/10 n, which equals 3/10 n plus 26. Then we subtract 3/10 here, subtract 3/10 here, and that will give us 4/10 n, which equals 26. And we could also reduce this fraction into 2/5 n, which equals 26. Then we could do the reciprocal on both sides, times it by 5/2, times it by 5/2. We know this will equal 1, so this already cancels out. But then we could do this. So we could do 1 over here and 13 over here. 5 times 13 is 65, so n equals 65. That's how I got my answer right here, which is 65. So this is how I got this answer. So let's move on from page 127 to the next page. Let's move on to page 128. Page 128, lesson 10-2, activity 10. So, that lesson 10-2 practice. So, number 12 says, solve for x, and where 180 subtract x equals 10 plus 2, in parentheses, 90 subtract x. So this was just like the problem we solved in page number 124. 124, try these A. So I would like you guys to solve this on your own because we already had practice of this problem. And number 13 is a real world situation in which they give you the formula of the triangle, because we have to find this thing, and then we have to find the height of this triangle right here. So they give you the area of the triangle, and then they give you the area, so you put in the area over here, and then they also give you the base, so you put in the base here, and then you need to find the height. So what you could do is you could do 126 equals 1/2 times 12 times h. So then you could do 6, then you could distributive property, you could do 6 plus 1/2 h equals 126, and then you could solve it from there. And this is just like number 12. So if you could solve number 12, you could solve number 14 too. Number 15 is just like the problem we had on the previous page, page number 127, number 5. So you could solve number 15 on your own too, and I want you guys to solve some on your own. And this is also a continuation, number 16 of number 15. So if you could solve this, you could also solve this. So number 17 is create a model and solve. We did that in the previous page too. We did that previous page, like try these B. We did this one. This is just like a 120 on page 125. We did that. That's the same thing over here, and this is also like on the previous page we did right here. So page 126. So you guys can solve this. And so number 17, A and B, you guys could do that. So number 18, we did this. Let's read this together and I'll explain you the how to get to the answer. So number 18 said, reason abstractly. What does it mean for an equation to have no solution? So let's focus on this question. We'll move on to next. So equation to have no solution, like we looked in the last page, it means that let's get a Michaela. So it means that the equation is not true and the equation doesn't equal each other. So that's the answer you should be writing for this. And let's read the next question. In number 18, how is it possible for one equation to have many solutions? So the word for that is infinitely many solutions, and we also encountered that on the previous page, page number 127. So in Gabriella's, we see that the both sides of the equation equal each other, so they can have any solution, and then they could be equaling each other if we put the same solution in here. So that's how equations have many solutions. So let's move on from page 128 to the next page, 129. Activity 10, and this is activity 10 practice. So we have all the lesson practice in here, and the next page which we'll get to later. So this is just like the problems you guys have solved on the previous pages, which you probably already know. And number 6 is a little tricky, so I'll go through this with you guys. So number 6 says, determine whether the equation y subtract y equals y is sometimes, always, or never true. Justify your response with examples. So, we can know that any number that has a value won't be true, because then the y will equal 0. So, the only number which has no number value is 0. So if we put in 0, subtract 0 equals 0. So this is true. So the answer to this is going to be sometimes true. And an example would be 0 subtract 0 equals 0. Okay, and for number 7, what you could do is you could it's just like the previous questions we did, so you can solve number 7 also to get more practice. And number 8 is just like some problems we did, and it just says that what's which could be the following first step, so you just have to think that what will you do next, which will be that you could think of that first you have to add 3 to both sides, or subtract 4, or divide by -3, or subtract 4 subtract 3. So you have to do this. This is a little bit tricky, but I want you guys to do this. And number 9 is just like what we did on previous pages, so you guys can do that. Number 10 is what we did on the previous page, 127, in page 127, so you guys could do that. And number 11 is similar to number 13 on this page, so you guys could do if you did number 13, you guys could also probably do number 11. So let's move on from page 129 to page 130. Page 130, this is activity 10, and this is also the continuation of the practice. Okay? Right now, we're on page 130, activity 10, and it's continued. So we are on activity lesson 10-2's activity practice. So we have to solve for x, so in this problems. So number 12 is just like the previous problems we encountered on 129 over here. We encountered problems like that on 1 through 5. So if you guys could solve that problem, so you guys could probably solve problems from 12 through 15, because they're just like the problems on the previous page. And this is number 16. It's just like the problem on the previous page, which the problem is number 8. So if you guys can solve number 8, you guys could probably solve number 16 too. So number 17 is also like problem 15. So if you guys can solve 15, problem 17 will be really easy for you guys. Number 18 is just like 16, but instead of telling what operation you're gonna do next, you're just gonna say what step is gonna be next. So this is pretty similar to 16. So if you guys could solve 16, you can solve 18 too. Number 19 is kind of like, it's almost the same as number 7 on page 129. So you guys can solve number 7. You guys can probably solve number 129. I mean number 19. And number 20 is just substituting in which of the solutions is a solution for this. So you can just solve in -10, -5, or you can actually solve this equation and see which one works. So you can do these two options. And number 21 is just like number 12 through 15. So you guys could solve that. You guys could probably solve this. Number 22 is a little tricky, so let's read this together and let's solve it together. So number 22 says, why is it important to be able to use properties of numbers in equality when solving an equation? So, why is it important? We use properties to isolate the variable and constant on different sides of the equation. So that's why it's important, so we don't get mixed up. So the answer to this would be, it is important to be able to use properties of numbers in equality when solving an equation, so we can isolate the variable on one side of the equation. So I hope you understood all of this, and thank you for watching this video. And in the next video, we will be doing the meta assessment 1 that will be after activity 10. And thank you.